Hello everyone. Today we are going to discuss about another type of energy. If you can recollect, in our previous classes we have learned about various types of energy. And today's class we are going to learn about that among the types of energy, one type of energy. For example, if I place a spoon in a hot cup or glass of tea. After some time, even the spoon, when touched, is felt warm. How is this occurring? It so occurs as when a hot object comes in contact with a cold object. The heat from the hot object is transferred to the colder object, and that is what we call it as heat energy. And then our heat is being measured in joules. So the topic what we are going to discuss today is about heat, right? So this heat energy is being measured in joules, usually represented by capital G. Then coming to, now what is the cheapest source of heat energy? Did you come across any cheapest source of heat energy? Right. Sun is the cheapest source of heat energy. Now tell me one thing. Is that the heat from the sun and a hot cup of tea or coffee is same, or the coldness in the snow and a glass of lemonade, a chilled lemonade, is equal? No. So, to measure the degree of hotness or coldness, we use, or the degree of hotness or the degree of coldness of an object is given by what we call it as temperature. So, our today's topic is heat and temperature. Now, how is temperature measured? It is measured in Kelvin. It is measured in Kelvin and denoted by K. Right? So, the degree of hotness and coolness of an object is what is called as temperature. Whereas heat, where the energy from the hot object is transferred to a cooler object, that we call it as a heat energy. So that is the difference between heat and temperature. Now, as such, how is that we are going to measure this hotness and coldness? So we use an instrument to measure. Can you tell me what is the instrument to measure the temperature? Right. It is what we call it as a thermometer. So, thermometer is used to measure temperature. Now, what does this thermometer consist of? How is that? It is measuring the hotness or coldness of an object. As such, right? As such, the parts of the thermometer. We are going to discuss now about the parts of the thermometer. It consists of a bulb, right? Draw along with me. It consists of a bulb. And this bulb is filled with, this bulb is filled with mercury or alcohol. Now you may have a doubt. Why is that it is being filled with mercury or alcohol? First we'll discuss with mercury. Why is it being filled with mercury? Because mercury can stay in a liquid state in a high temperatures also. So that is the main reason why we fill the bulb of the thermometer with mercury. And the second one is, it is a very shiny metal where you can easily see or record the temperatures. That is also one more thing why we use mercury in the thermometer. And then it doesn't stick, it is very slippery. So that is also a reason. One drawback we have where it is costlier and then it is highly toxic. So that's the reason we prefer alcohol to some thermometers. Alcohol is cheaper than mercury. We can use. But here it can measure temperatures from minus 70 degrees to only 78 degrees. Beyond 78 degrees, it cannot record the temperature. So that is the drawback in using alcohol. So as such, the bulb of the thermometer is either filled with mercury or either it is filled with alcohol. Now after the bulb, and this bulb is made in contact with the object, with the hotter object or cooler object where the temperature is being measured. Now continuous with this mercury, that is the bulb, you have a glass, you have a glass tube, okay, where one end of the glass tube is closed. You have a glass tube where one end of it is being closed, right? And then over here you have a constriction or what we call it as a bend also. Right, I'll tell you when we are dealing with the types of temperature why you have this bend nearer to the bulb. Then that glass tube, then above that glass tube you have some scale. To read the temperature we have scale written on the glass tube. This is how a temperature thermometer looks like. Fine. So as such, now we'll discuss about the different types of thermometers you have come across. Can you name them? Right? Yes. Good. You have about your clinical thermometer, which the doctor uses. Then along with the clinical thermometer, nowadays we get digital thermometers. And then you have laboratory thermometers also. Fine. These are the three different kinds of thermometers where we use regularly. Now coming to clinical thermometer, right? Coming to clinical thermometer, here the clinical thermometer is used to measure our body temperature. It is used to measure our body temperature. And I told you about the scale. Now here the clinical thermometer has a normal body temperature is in the clinical thermometer 37 degrees centigrade, right, or 98.6 degrees Fahrenheit. When we come to the scales, you will learn about Celsius and the Fahrenheit scales. So as such, clinical thermometer is being used to measure the body temperature, and a normal body temperature in Celsius scale is 37 degrees centigrade and in Fahrenheit scale it is 98.6 degrees Fahrenheit. Fine. This is the normal temperature. Now if at all it is the normal temperature shows the temperature of the body shows 40 degrees centigrade or 104 degrees Fahrenheit, then that is a severe case where we need to rush to the medical treatment. Fine. So that is the maximum temperature. Beyond that, we cannot survive. So as such, we need to rush to the doctor for further medical treatment. But when we are talking about the normal temperature, that may differ. For example, if you are sitting coolly inside the house, the temperature is different. When you are running, doing some exercises, some activity, or you have gone to a region where it is very cool, then the body temperature differs. It depends upon the age also. Now, as such, in the clinical thermometer, What are the precautions? How is that we are going to use a clinical thermometer? I told you, I will tell you about this bend when we come to clinical thermometer. This bend is what we call it as kink. Now I'll tell you why is this kink been placed just above the butt. Now it so happened. Now I want to measure my temperature. I'll place my thermometer inside my mouth right under the tongue such that the bulb of the thermometer is touching my tongue. Then as such, after some time, after few minutes, right, I remove it and try to see my temperature. At that time when I'm removing it, this kink over here, right, when I'm changing the position of the thermometer, this kink will not allow the reading to fall down. It doesn't allow the line of the mercury. For example, my temperature is this. So it doesn't allow, even though it has been removed from its position, made it horizontal, the mercury is standing over here until and unless we read the temperature. It doesn't. This kink doesn't allow the mercury to come back into the bulb. Now, there are certain precautions which we have to use while we are using clinical thermometer. It so happens that if you have visited the hospitals over there, the doctor uses, he doesn't have each thermometer, like your syringes, he doesn't use thermometers separately for everybody. He uses only one single thermometer. But he cleans it, he washes it thoroughly with an antiseptic solution. He dips in the alcohol also such that it has been cleansed thoroughly. Then only he uses for the next patient. Now, before he is going to put it in to the next patient, now he has to check that whether it has come back to the normal temperature. That is, it should be below 35 and it should be 98 degrees. Then only that is where he can place it into the next patient. So for that to happen, for example, if it is showing for me 100 degrees centigrade, so to come back 100 degrees Fahrenheit, to come back to its normal, what is that I do? I just give a jerk. When we give that jerk, then the mercury comes back to its bulb. Fine. So these precautions need to be taken because this has been made up of glass, right? The stem of the thermometer is made up of glass. We should be very careful enough, wherein we shouldn't hit to any other harder substance where it breaks. And while reading the thermometer also, you have to place at your side of your eye, and then you can just tilt the thermometer to see that shiny line being shown in the thermometer. Fine. So these are certain precautions where we need to take while handling clinical thermometer. And for children like you nowadays, we have a better equipment, that is what is digital thermometer, where there's no usage of a bulb or mercury and all. Directly, if you put it out into your mouth, then you get a beep sound where naturally the reading is being given in the place. So directly you can note down the reading. That is your digital thermometer. Now coming to the laboratory thermometer. You may feel, why is that a thermometer? Why cannot we use this type of thermometers, clinical thermometers in the lab? In the lab, we need thermometers which can measure up to minus 10 degrees centigrade to 110 degrees 110 degrees centigrade. So as such, because of that, we have these special thermometers called as laboratory thermometers. That is also similar. It has a bulb, it has a glass tube and all, but it is a bit longer than what we use or we can see in a clinical thermometer. Now, while taking the measurement of the temperature, we should see that, especially in laboratory thermometer, that the bulb is surrounded by the material. For example, if you are placing the thermometer into the ice cubes, so the bulb of the thermometer should be surrounded with the ice cubes. Then only you'll get the exact temperature. And then it should stand straight. It shouldn't tilt. the thermometer, lab thermometer shouldn't tilt here and there. So these are certain precautions which we need to take while using the laboratory thermometer. The one common will be you should be very careful while you are using it, because even that stem of the lab thermometer is also made up of glass. Should be careful enough in handling the laboratory thermometer. Okay. To end the session, we'll discuss something related to temperature scales. Now, as such, for measuring it, you require certain scales. So we have three different types of scales used, right? One is, till now I was going on using degrees centigrade. So that scale is what is called as Celsius scale. That is what is called as Celsius scale. Celsius scale. Fine. This Celsius scale has, it depends upon usually the freezing point and the boiling point of water is usually being taken. Here the lower fixed point and the upper fixed point is being taken. And this scale was first given by to us by Anders Celsius. So that's, we call it as Celsius scale, and it is always been donated by degrees centigrade. We call it as degrees Celsius, right? We call it as degrees Celsius. Now, as such, now the units on the scale. Now, here the freezing point of water is taken as 0 degrees Celsius, 0 degrees Celsius. That becomes the lower fixed point, and the boiling point of water is 100 degrees Celsius. That becomes the upper fixed point. In between, you have 100 units. Right? In between, you have 100 units. That is what is your Celsius scale. Then we move on to the next scale, that is Fahrenheit scale. Right? Also named after the scientist, right? Daniel Gabriel Fahrenheit. So after his name, we got this scale, what we call it as Fahrenheit scale. Daniel Gabriel Fahrenheit. Fine. Here also the boiling point and the freezing point of water is being taken, but here the freezing point of water is 32 degrees Fahrenheit, right? This becomes the lower fixed point, and the boiling point of water over here is 212 degrees Fahrenheit. This becomes the upper fixed point. In between these, you have about 180 divisions. So the scale has been divided into 180 divisions, which we call it as units. In between these 2 points, you have 180 divisions. Then the last scale what we are talking about is Kelvin scale. Right? Kelvin scale. Scientist Lord Kelvin, who has given us this scale, where this is approximately, right? Then the lower fixed point over here is 273 degrees Kelvin, right? We don't call as degrees, 273 Kelvin, and the upper fixed point over here is 373 Kelvin approximately, right? It is approximately. Now we have to learn how to convert from one scale into the other scale. For example, if I want to convert Celsius to Fahrenheit scale, right? if I want to convert Celsius to Fahrenheit scales. If I want to convert Celsius scale into Fahrenheit scale. So it is degree Fahrenheit is equals to degree centigrade, right? Into 9 by 5, right? 9 by 5 plus 32. To convert Celsius scale into Fahrenheit, this is the formula we use. Degree centigrade into 9 by 5 plus 32. Fine. To convert Fahrenheit into Celsius scale. To convert Fahrenheit into Celsius scale, we use this formula degrees Fahrenheit minus 32 into 5 by 9 to convert Fahrenheit into Celsius scale. Now, if you want to convert Celsius to Kelvin scale, if you want to convert Celsius, degrees Celsius into Kelvin scale, Kelvin is equals to degrees Celsius plus 273. So you need to remember these three formulas where it is being useful for us to convert from one scale into the other scale. Is that clear? Okay, beta. Fine. Meet you again in the next.